Hello students, welcome to your channel. Please like, share and subscribe your own channel, School Studies. School Studies is pleased to announce the launch of our educational website, Patel section. After years of hard work and dedication, we are delighted to officially announce the launch. Today we will see a video related to NCERT solution for class 10th Mathematics, Chapter 15, Probability, Exercise 15.1. So let's solve textbook exercise. The first question, complete the following statement. Probability of an event E plus probability of an event E plus probability of the event not E equals to 1. The probability of an event that cannot happen is 0. Such an event is called an impossible event. The probability of an event that is certain to happen is 1. Such an event is called a sure or certain event. The sum of the probabilities of all the elementary events of an experiment is 1. The probability of an event is greater than or equal to 0 and less than or equal to 1. Second question, which of the following experiments have equally likely outcomes? Explain. So a driver attempts to start a car. The car starts or does not start. This statement does not have equally likely outcome as the car may or may not start depending upon various factors like fuel, etc. A player attempts to shoot a basketball. He shoots or misses the shot. Even this statement does not have equally likely outcome as the player may shoot or miss the shot. A trial is made to solution a true or false question. The solution is right or wrong. This statement has equally likely outcome as it is known that the solution is either right or wrong. A baby is born. It is a boy or a girl. This statement also has a equally likely outcome as it is known that the newly born baby can either be a boy or a girl. Third question. Why is tossing a coin considered to be a fair way of deciding which team should get the ball at the beginning of the football game? Tossing of a coin is a fair way of deciding because the number of possible outcomes are only 2, either head or tail. Since these 2 outcomes are equally likely outcome, tossing is unpredictable and is considered to be completely unbiased. Next, which of the following cannot be the probability of an event? 2 by 3 minus 1 by 1.5, 15% and 0.7. The probability of any event E always lies between 0 and 1. That is 0 less than equals to P less than equals to E 1. So from the above option B, that is minus 1.5 cannot be the probability of an event. Next, if PE equals to 0.05, what is the probability of not E? So PE plus P not E equals to 1. It is given that PE equals to 0.05. So P not E equals to 1 minus PE, that is 1 minus 0.05. So P not E equals to 0.95. Next, a bag contains lemon flavored candies only. Malini takes out one candy without looking into the bag. What is the probability that she takes out an orange flavored candy or lemon flavored candy? We know that the bag only contains lemon flavored candy, so the number of orange flavored candies will be 0. That is 0 upon 1 equals to 0. As there are only lemon flavored candy, so P lemon flavored candy equals to 1, or we can write 100%. Next, it is given that in a group of 3 students, the probability of 2 students not having the same birth date is 0.992. What is the probability that the 2 students have the same birth date? Let the event wherein two students having the same birth date be E. Given PE equals to 0.992. We know PE plus P not equals to 1. So P not equals to 1 minus 0.992, that is 0.008. So this is the probability that our two students have the same birth date. Next, a bag contains 3 red balls and 5 black balls. A ball is drawn at random from the bag. What is the probability that the ball drawn is red? Second, not red. The total number of balls equals to number of red ball plus number of black balls. So the total number of balls equals to 5 plus 3, that is 8. We know that the probability of an event is the ratio between the number of the favorable outcomes and the total number of outcome. So first is probability of drawing red balls. So P red ball equals to number of red balls upon total number of balls, that is 3 upon 8. Probability of drawing black balls. So number of black balls are 5. So 5 upon 8. Next, a box contains 5 red marbles, 8 white marbles, and 4 green marbles. One marble is taken out of the box at random. What is the probability that a marble taken out will be red, white or not green? So total number of balls equals to 5 plus 8 plus 4, that is 17. PE for formula is number of favorable outcomes upon total number of outcome. For first, that is total number of red balls. So red balls are 5. So 5 upon 17, we can divide that. So it will become 0.29. Total number of white balls. So white balls are 8. So 8 upon 17. So 0.47. Total number of green balls, that is 4. So 4 upon 17 equals to 0.23. But we want P not green. So 1 minus P green ball, that is 1 minus 4 upon 7. So we will get 0.77. Next, a piggy bank contains 150 paisa coins, 50 rupee 1 coins, 20 rupee 2 coins and 10 rupee 5 coins. If it is equally likely that one of the coins will fall out when the bank is turned upside down, what is the probability that the coin will be a 50 paisa coin, will not be a 5 rupee coin? So total number of coin equals to 100 plus 50 plus 20 plus 10, that is 180. Formula is number of favorable outcome upon total number of outcomes. So first is total number of 50 paisa coin equals to 100. So it is 100 upon 180. So we can reduce that. It will become 5 upon 9. We can divide that. So it will become 0.55. Total number of rupee 5 coin, that is 10. So 10 upon 180, that is 1 upon 18, equals to 0.055. So not rupee 5 coin equals to 1 minus P rupee 5 coin. So 1 minus 0.055, that is 0.945. Next, Gopi buys a fish from a shop for his aquarium. The shopkeeper takes out one fish at random from a tank containing 5 male fish and 8 female fish. What is the probability that the fish taken out is the male fish? So total fish are 5 male and 8 female. So that is 13 total fishes are there. Total number of male fish is 5. So 5 upon 13. So we will get 0.38 as the probability. Next, a game of chance consists of spinning an arrow which comes to rest pointing at a number of the one of the numbers, that is 1, 2, 3, 4, 5, 6, 7, 8, and these are equally likely outcomes. What is the probability that it will point at 8, an odd number, a number greater than 2, a number less than 9? So total number of outcome is 8. First, we have to find total number of favorable outcomes, that is 8 equals to 1. So 1 upon 8, that is 0.125. Total number of odd numbers, that is 4. Odd is 1, 3, 5 and 7. There are 4 odd numbers. So 4 upon 8, that is 1 upon 2, means 0.5. total numbers greater than 2. So 6 numbers are there which is greater than 2. 3, 4, 5, 6, 7 and 8. So 6 upon 8, that is 3 upon 4, or we can say 0.75. Total numbers less than 9. There are 8 numbers which is less than 9. So 1, 2, 3, 4, 5, 6, 7 and 8. So 8 upon 8 equals to 1. Next, a die is thrown once. Find the probability of getting a prime number, a number lying between 2 and 6, and odd number. So total possible events when a die is thrown equals to 6. That is 1, 2, 3, 4, 5 and 6. So first we have to find the total number of prime numbers. So there are 3 prime numbers, 2, 5 and 2, 3 and 5. So 3 upon 6, that is half, equals to 0.5. Next we have to find the total numbers lying between 2 and 6. So there are 3 numbers which are lying between 2 and 6, that is 3, 4 and 5. So 3 upon 6 again, that is half, equals to 0.5. Next, total number of odd numbers, that is 3, 1, 3 and 5. So 3 upon 6, that is half, equals to 0.5. Next, a card is drawn from a well shuffled deck of 52 cards. Find the probability of getting a king of red color, a face card, a red face card, a jack of hearts, a spade and a queen of diamonds. So total number of outcomes, we know that in a cards there are 52 cards, and first we have to find the total number of king of red color, that is there are 2 kings of red color. So 2 upon 52, that is 1 upon 26. We can divide it and we get 0.038. Next, total number of face cards. So there are total 12 face cards. 12 upon 52, that is 3 upon 13. If we can reduce it, we will get 0.23. Total number of red face cards. So there are 6. 6 upon 52, 3 upon 26, so equals to 0.11. Total number of jack of hearts, that is 1. So 1 upon 52, that is 0.019. Total numbers of king of spade, that is 13. 13 upon 52, 1 upon 4, or we can say 0.25. Total number of queen of diamonds, that is 1. So 1 upon 52, that is 0.019. Next, 5 cards, the 10, jack, queen, king and ace of diamonds are well shuffled with their face downwards. One card is then picked up at random. What is the probability that the card is the queen? If queen is drawn at and put aside, what is the probability that the second card picked up is an ace or an queen? So total number of cards are 5. So first we have to find number of queen, that is 1. There are only 1 queen. So 1 upon 5, that is 0.2. If the queen is drawn and put aside, the total number of cards left will be 4. So total number of ace is 1. So 1 upon 4, that is 0.25. Total number of queens, 0, because queen is already picked. So 0 upon 4, that is 0. Next, 12 defective pens are accidentally mixed with 132 good ones. It is not possible to just look at a pen and tell whether or not it is defective. One pen is taken out at random from this lot. Determine the probability that the pen taken out is a good one. So number of pen equals to number of defective pens plus number of good pens. So total number of pens equals to 132 plus 12, that is 144 pens. PE we have to find. So P picking a good pen, 132 upon 144, that is 11 upon 12, that is 0.916. Next, a lot of 20 bulbs contain 4 defective ones. One bulb is drawn at random from a lot. What is the probability that this bulb is defective? Suppose the bulb drawn is first is not defective and is not replaced. Now one bulb is drawn at random from the rest. What is the probability that this bulb is not defective? So there are 4 defective bulbs. Total number of bulbs is 20. So probability of getting the defective bulbs is 4 upon 20, that is 1 upon 5 equals to 0.2. Since one more non-defective bulb is drawn, then the total numbers of bulbs left are 19. So the total number of events equals to 19. Number of non-defective bulbs equals to 19 minus 4, that is 15. So 15 upon 19, that is 0.789. Next, a box contains 90 discs which are numbered from 1 to 90. If one disc is drawn at random from the box, find the probability that it bears a two-digit number, a perfect square number, a number divisible by 5. So total number of discs is 90. So total number of discs having two-digit number is 81. Since 1 to 9 are single digit numbers, and so total two digit numbers are 90 minus 9, that is 81. So 81 upon 90 equals to 9 upon 10, that is 0.9. Total number of perfect square, that is there are 9 perfect squares, so 9 upon 90, that is 1 upon 10 equals to 0.1. So total number of numbers which are divisible by 5, there are 18 numbers which are divisible by 5. So P equals to 18 upon 90, that is 1 upon 5 equals to 0.2. A child has a die whose 6 faces shows the letters as given below. These are the letters. The die is thrown once. What is the probability of getting A? D. So total numbers of possible outcomes are 6. So total number of faces having A on it, there are 2A. So 2 upon 6, that is 1 upon 3 equals to 0.33. Total number of faces having D on it, that is 1. So 1 upon 6 equals to 0.166. Suppose you drop a die at random on a rectangular region shows in figure 15.6. What is the probability that it will land inside the circle with diameter 1 centimeter? First, here we have to calculate the area of rectangle and the area of circle. Here the area of rectangle is possible outcome and the area of circle will be the favorable outcome. So the area of rectangle equals to 3 into 2 meter square, that is 6 meters square. And area of circle equals to pi r square, that is 0.78. So probability that die will land inside the circle equals to 0.13. Next, a lot consists of 144 ball pens, of which 20 are defective and the others are good. You will buy a pen if it is good, but will not buy if it is defective. The shopkeeper draws one pen at random and gives it to her. What is the probability that she will buy it? She will not buy it. So there are total number of outcome is 144, defectives are 20, and we have to find the total number of events in which she buys them. So 124, 144 minus 20, so that is 144 defective, non-defective pens. So 144 upon 124 upon 144, that is 31 upon 36 equals to 0.86. Total number of events in which she will not buy them, so there are 20 non-defective. So 20 upon 144 equals to 5 upon 36 equals to 0.138. Next, refer to example 13. Complete the following table. A student argues that there are 11 possible outcomes: 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12. Therefore, each of them has a probability 1 upon 11. Do you agree with this argument? Justify your solution. Now, if 2 dice are thrown, the possible events are 36. It is given that to get the sum as 2, the probability is 1 upon 36 as the only possible outcome, that is 1, 1. For getting the sum as 3, the possible events or outcome sum 3 equals to 1 upon 1, 2 or 2, 1. So 2 upon 36. Similarly, P sum 4, the 3 upon 36, sum 5, 4 upon 36, sum 6, 5 upon 36, sum 7, 6 upon 36 and so on till sum 12, that is 1 upon 36. So the probability table says 1 upon 36, 2 upon 36, 3 upon 36 up till 1 upon 36 again. So the argument is not correct as it already justified in that number of all possible outcome is 36 and not 11. A game consists of tossing a 1 rupee coin 3 times and nothing its outcome each time. Hanif wins if all the tosses will give the same result, that is 3 heads or 3 tails, and loses otherwise. Calculate the probability that Hanif will lose the game. So total number of outcome is 8. Total outcomes in which the Hanif will lose the game is 6. So 6 upon 8, that is 3 upon 4 equals to 0.75. A die is thrown twice. What is the probability that 5 will not come up either time? 5 will come up at least once. Throwing a dice twice and throwing 2 dice simultaneously are treated as the same experiment. So the possible outcome is 36. We have to consider a PA equals to 5 comes in the first throw. So 6 upon 36. PB 5 comes in second throw, that is 6 upon 36. So P not B equals to 5 upon 36. Sorry, pi 5 upon 6. And P not A equals to 1 minus 6 upon 36, that is 5 upon 6. So the required probability is 5 upon 6 into 5 upon 6, that is 25 upon 36. Next, which of the following arguments are correct and which are not correct? Give reason for your solution. If 2 coins are tossed simultaneously, there are 3 possible outcomes: 2 heads, 2 tails, and 1 of each. Therefore, for each of these outcomes, the probability is 1 upon 3. So first is all the possible outcomes are 4, HH, HT, TH, and TT. P getting 2 heads is 1 by 4 and getting 1 of each is 2 by 4, that is half. The statement is incorrect. A die is thrown, there are 2 possible outcomes, an odd and or an even. Therefore the probability of getting the odd is half. Since the 2 outcomes are equally likely, the statement is correct. So this was exercise 15.1 of NCERT solution for class 10th mathematics. I hope you like my video. Thanks for watching my video. Thank you. Please leave comment, question or doubts in comment section if you have any, or you can drop a mail to us. You will find my email ID at the end of this video. You can also join us on Facebook page, follow us on Instagram, connect us on LinkedIn or tweet us on Twitter. Thanks for watching my video. Thank you.